Hi, my name is Akhil Sai Patel. I am discussing about standard electrode potential. I am from aeronautical engineering. This is my concept video on chemistry. Electrode potential is the tendency of a metal to go oxidation or reduce when it is placed in a solution on its own salt is called electrode potential. When a metal is placed in a solution containing its own ions, then the metal undergoes their oxidation and reduction. If the metal undergoes oxidation, then the positive metal ion may pass into the solution. M gives rise to M plus n electrons. If the metal undergoes reduction, the negative ions may deposited over the metal, that is M plus. Zn Zns4 when Zn zinc is placed in a solution of its own salt, zinc undergoes oxidation with the release of electrons. The electrons liberated in the process accumulate over the surface of the metal, and hence the metal is negatively charged. Now the negatively charged metal attracts the positive ions from the solution, and hence formation of a double layer takes place near the surface of the metal. This is the when Zn undergoes in Zns4. Cu in CuSO4. When Cu is placed in the solution of CuSO4, the copper ions in the solution gets deposited over the metal, and hence the metal becomes positively charged. The positively charged metal attracts the negative charged sulfate ions in the solution, and hence a doubly charged layer is formed near the metal. When Cu is dipped in CuSO4 solution, Cu plus 2 ions are produced in this, and they are formed near to the metal. They are positively charged. Single electrode potential. It is the measurement of tendency of a metal electrode to lose or gain electrons when it is in contact with a solution of its own salt. Standard electrode potential. When it is measured of tendency of an electrode to lose or gain electrons when it is in contact with a solution of its own salt of 1 molar concentration at 25 degrees Celsius. And in this concept video we discussing about that standard electrode potential, the potential of a redox system to lose or gain electrons when compared to the standard electrode potential, standard hydrogen electrode potential assigned as values of 0 volts. Definition of standard electrode potential: the potential difference between a standard hydrogen electrode potential and a metal which is immersed in a solution containing metal ion at 1 mole dm. In any reaction, in any reduction oxidation of equation, the electrons are gained by the species of the left hand side. Cu plus 2 electrons Cu in this equilibrium, and so if a more powerful reduction agent is allowed entering into electric contact with the above system, it can force the copper ion to accept. The electron potential measures the tendency of electron to flow away from or towards a redox equilibrium. They are always measured with respect to standard hydrogen electrode, which is assigned as the value of 0 volt. Equilibrium redox system with the reduced side, usually a metal more reactive than hydrogen, has a negatively electron potential, that is they can lose electron more easily than hydrogen. Equilibrium redox system with the reduction side less reactive than hydrogen have positive electrode potential, that is they can lose electrons less easily than hydrogen. For example, zinc has started standard hydrogen electrode of minus 0.76 volts. Consequently, the equilibrium Zn plus 2 electrons has tendency to move to right side than the equilibrium H2 plus 2E. Hence, if the two equilibria are about in electric contact using an external wire and A salt bridge the electrons with the two equations then may be immersed together to give the reaction occur in the whole cell. Zn gives Zn plus 2 plus 2 electrons, 2H plus 2 electrons give hydrogen. Overall cell reaction is Zn plus 2H2. The diagram of a standard hydrogen electrode or standard electrode is given. The salt bridge is between these two electrodes. Zn plus 2 electrons at left side and H plus ions at right side. This is the hydrogen standard electrode potential which we measured represent the cells. The whole cell can be represented by showing the half cell is in order of phase solid slash solution slash salt bridge slash solution slash solid. This is the representation of the cell. Thank you. This is about my concept video on standard electrode potential.